comparing numbers first. Whenever you compare numbers in math, you're using these symbols. What is that first symbol called? It's not called an alligator mouth. This one is greater than. The second one is less than. And this one is equal to. Whenever you are comparing numbers, you need to have them in decimal form. So sometimes you get lucky and you're just comparing a decimal to a decimal. So for instance, if we had the problem 0.9 compared to 0.17, and we had to say, do we use a greater than sign, less than sign, or equal to sign? Do you know how to compare decimal numbers? Yeah. What do you do to compare decimal numbers? So you look at one place value at a time. To help you, sometimes it's easier than others. So to help you, you can always line up your decimals. And when you line up your decimals, that automatically lines up your place values. So we can see in the ones place that we have the same digit, so they're equal in the ones place. However, in the tens place, they're different, aren't they? We have a 9 in the tens place and a 1 in the tens place. So because they have a difference in the tens place, the hundreds place doesn't matter at all. So we're really comparing a 9 to a 1. Which one's bigger, 9 or 1? 9 is bigger. So 0.9 is greater than 0.17. I have a feeling when some people saw this, they might have instantly said, oh, well, 17 is bigger than 9, so 0.9 is less than 0.17. But that's not true. Another thing that can help you is making sure, or making it so that they have the same amount of digits after the decimal. If I wanted to make this have a second digit, I could put a 0 in here. And now that's like having 90 cents versus 17 cents. 90 cents is greater than 17 cents. Okay? So we're going to compare everything in decimal form, or turn it into a whole number. For instance, if we have a perfect square, like if we had the square root of 16 compared to 4.72. We talked about these perfect squares. What is the square root of 16? 4. So is 4 greater than, less than, or equal to 4.72? It is less than. Sometimes we may need to estimate the square root if it's not a perfect square. For instance, like the square root of 10, we would have to estimate what the value is to be able to compare it, which is harder, but we had a whole day where we spent just estimating those perfect squares. Sometimes you have a fraction compared to a decimal. So if you wanted to compare a fraction to a decimal, you would need to turn this fraction into a decimal, which 3/4 is 0.75. It's not the same thing. Oh, it's 0.6, I thought you meant. So let's make them have the same amount of digits after the decimal. This one has 2, so let's make this one have 2. So 75 cents compared to 60 cents, is that greater than, less than, or equal to? Greater than. All right, next, to take it a little bit further, if you have more than 2 numbers that you need to compare, then that would be ordering. Ordering either from least to greatest or greatest to least. Make sure that you are always reading the directions carefully. Sometimes it'll say least to greatest, and sometimes it says greatest to least. So order. So I'm going to give you some numbers that I want us to order from least to greatest. just write these numbers in your notes. 0, a negative square root of 2, the square root of 5, 13 over 4, and 0.97. So we have 5 numbers that we want to order from least to greatest. So, looking at these 5 numbers, it should be very obvious which one comes first. Any guesses? Negative.
Yeah!
Not the 0, the negative. There's only one negative. So no matter what, this negative is the smallest number here. Now I'm going to put a little check mark above this because I used it. Now before I compare my other numbers, I'm going to estimate the square root of 5. What is a perfect square that is close to the square root of 5?
4.
Square root of 4. The square root of 4 is what? 2. So wouldn't you agree this is a little bit more than 2? So I'm going to say 2 point something. I'm not going to worry about point what it is. 2 point something. If I need to get more specific later on, then if I had another thing that was 2 point something, then I'd have to compare them, and then I'd worry about it. But I don't. 13 over 4, we worked yesterday and the day before on that. 13 divided by 4. So that's 3 something, right? No, we could do it, but we don't really need to. 3 point something. And then 0.97. Okay. So what would be next? Of these 4 things that we have left, what would be next? 0. Right? 0. Okay? So we have something that's 2 something, 3 something, and 0.97. 0.97, because it doesn't have a whole number at all. Now what? Good. I'm glad that you said the square root of 5 and not 2 point something. When we give our order, we want to have it in the original form. So I want to write the square root of 5. And then last would be 13 over 4. And that is our answer. So it takes time, and a lot of people don't like doing math problems that take time. They like having stuff that's quick, right? So that's one of the reasons that people get these wrong, is because it takes time and it takes a lot of work to be able to order them from least to greatest when they're not all in the same form. They're not all decimals or all fractions or whatever. Okay. Let's do one more in your notes instead of me passing out that paper, because it'll just, we'll use all of our time passing out the paper instead of actually working. Let's do negative 1.5, negative square root of 6, positive 1.5, 3, and 7 over 5. Now on this one, we can't just say, oh, the negative is the smallest. We know that these two are going to be the smallest, correct? But we need to figure out which one's smaller than the other one. So let's estimate the square root of 6. We know it's going to be negative something, but the square root of 6 is close to what? It's between what and what?
8.
Square root of 4 and the square root of 9, right? Which is 2 and 3. Square root of 4, square root of 9, so that's between 2 and 3. So I'm going to say negative 2 point something, okay? Be very careful. What's smaller, negative 1 or negative 2? Negative 2 is smaller. So my first number is going to be negative square root of 6, and then my negative 1.5. So now let's focus on those last 3 positive numbers. I have 1.5, 3, and 7 over 5. Well, I think it's pretty obvious that 3 is bigger than 1.5, but what is 7 over 5 equal? 7 divided by 5. 1 and 2/5. Well, are you going to be able to compare that to 1.5? We better not write that as 1 and 2/5 then. We better write it as a decimal. So we had to put in a decimal. There's a reason I went over how to do that. It'd be 1.4. What's the smallest, 1.5 or 1.4? 1.4. So 7 over 5 would be next in our list, then 1.5, and then your 3. So there is your final answer.